Okay, good morning everyone. Happy Monday. I hope everybody had a lovely weekend. I think we'll get ready to kick things off. So thanks very much for joining us today and taking time out of your busy schedules to come and learn about ReCap and what you could be utilising it for. My name is Victoria Adams and I'm an AEC sales consultant at Pentagon Solutions. I'll be your host today along with Ashley McGinn, who's also part of our AEC consultant team, but on the technical side of things. Okay, so just before we get stuck into ReCap Part 3, I'd like to quickly just run through a little bit about Pentagon Solutions for those who may not know. So Pentagon Solutions started in 2002, so we'll be going 18 years strong. As you can see there on the map, we have 3 locations, Belfast, Cork and London, with our main office being situated in Belfast. We do also have training facilities in our offices operating across the whole of the UK and Ireland. So with 4 directors there at the top, Eamon Morgan, who is our commercial director, with David Gawley, Brendan Green and Chris McVicker on the technical side. So in very simple terms, we are a technology company who drive the adoption of technology software throughout the UK and Ireland, partnering with our clients to ensure that they're getting the most from their software through training and consultancy. So as software is a small part of what we do here at Pentagon, I just thought I'd shed a little light regarding some of the other solutions that we can provide and what sort of things we are helping our clients with on a day-to-day basis. So starting up in the right-hand corner there with the software side of things, that's why we're here today. So we are an Autodesk Gold partner and reseller of Autodesk technologies. We have been driving the adoption of these technologies for many years now, mainly in the AEC and MFG industry. We do also hold an ATC status, meaning that we are fully authorised and certified by Autodesk to carry out training in these technologies, and anyone who has previously trained with us or plans to in the future will receive an Autodesk certification as well. So moving on to BIM then, we do actually have a dedicated BIM department filled with expert knowledge in Pentagon Solutions. We were very early adopters of BIM, starting off in around 2007, and now we're a leading provider of BIM implementation consultancy services in the UK and Ireland. So we train, consult and advise our clients while also adhering to BIM standards on any BIM projects that we're involved in, and also our own BIM projects. Going hand in hand with that then, we're also BSI associate consultants, so helping our clients through their digital journey and achieving BSI accreditation. So just on the left-hand side there, Pentagon Solutions is actually in partnership with other technology solutions such as Accruent and Maintenance Connect. So this makes us proficient in asset lifecycle management systems and computerized maintenance management systems. We do also offer another solution for mobile surveying and inspections through a cloud-based application called KaiCloud. And the last solution I'd just like to mention is Pentagon Construction Intelligence there at the top. This is one of our latest technologies actually, and was created by ourselves through experience and just listening to our customer demands. It basically takes project data and measures quality, productivity and risk for our clients in the construction industry. Of course, for all the solutions just discussed, we do also offer Pentagon support, and support is something that is really important to us. As with any technology that we provide, we do want to ensure you always have the support you need. We can deliver this through an online fresh service portal, over the phone, by email and of course on site. However, support does of course go beyond just technical queries. We do also support our clients by partnering with them through training, consultancy and project support. So if anyone would like to hear more about some of the solutions we provide, or if you do need any of our assistance with some of your current projects, please do not hesitate to get in touch, as we don't just provide software. Okay, so just before kicking things off, I'd like to touch upon previously what we showed in part 1 and 2 of this series, just before getting stuck into today's part 3. So part 1 was the first webinar in a series of 3. It focused on an intro into Autodesk ReCap, how to create, edit and integrate point clouds into AutoCAD, and took a quick look at Navisworks. We also actually had a look at the work Pentagon has done with NI Water. We did consultancy for them to help the customer utilise their point cloud data, which ended up saving them a lot of time and money. So if you're interested in that, you can catch up on it. Part 2 was then the second webinar in the Autodesk ReCap workflow series, which built on the first one. by integrating point cloud data into Civil 3D, AutoCAD Map 3D and InfraWorks. So this really illustrated the importance of having the correct coordinate systems on projects to create, edit and share data. And finally then today, so part 3, what we'll be wrapping the series up with, again, a little bit more in depth than before. So today's webinar will highlight the configuration process for Revit and using shared coordinates with point cloud data for projects. Having the correct setup for project delivery is key across multiple platforms. So today Ashton will show the technical workflows for coordinate systems and point cloud integration. Please note, just a wee something there, you do not have to have watched part 1 or 2 to understand the content that we're showing today. However, if you do want to catch up on anything you've missed, you'll receive a recording of all 3 webinars, and they're also available via our website or YouTube channel. So just before I pass you over to Ashton to kick things off, I'd like to mention that we will also have a short Q&A at the end of the session. So if you do have any questions, please feel free to post them in the comments section, and we'll try to answer them live, or we will definitely follow up via email anyway. So I will now pass you across to Ashton, who will take you through the demonstration.
Thanks, Victoria. As Victoria said, my name's Ashlyn. I'm an AEC consultant here at Pentagon. Today we're going to be talking about the coordination systems within Revit and the correct way to bring our point cloud data into the best quality model. Basically, if you attended either of the previous webinars, welcome back. But if this is the first time you're attending one of these webinars, then hopefully you find something useful out of it. Previously, we talked about coordination systems within Civil. This one's going to be more based on how the point clouds can be brought in properly into Revit. It's important because there are numerous ways to set up coordinates. A consistent approach should be taken, because the third point there, correcting the models, can be time consuming if wrong. If the model coordinates of say a shared project aren't set up properly, it's going to cause more problems later down the line. So the purposes of this webinar is to sort of make you aware where these pitfalls can be, and just give you a bit of education on what's the best practice to set up these models. It's going to be based around point clouds, because the series is sort of tailored to ReCap and how we can edit and use point clouds within that to be brought into other pieces of software. Now, we had discussed before the digital workflows between the likes of ReCap, InfraWorks, Navisworks, AutoCAD, Revit, Civil 3D, that they all can work alongside each other to give an optimal output, but it's understanding how you bring these point clouds in that's going to be the crux of whether or not your model is of good quality and robust. The last point there, the survey point, and base point need to be set at the start of the project. This is what we're mainly going to be focusing on. Basically what the difference between these points are, why they're important, and how they integrate with point clouds themselves. So I'll give you a bit of background here. So the background on mapped coordinates, again, if you were at one of the previous webinars, you'll see that when we set up a model in Civil 3D, we set it up against a grid system. So it's mapped to a global sort of grid system that we select for a particular area. Now, in this series of webinars, we've been working off the Irish grid system. So we are going to be talking about that today. So it's important to note, though, that each sort of country, each area has differently mapped grid systems, because the world is round. Like, there's, there are questions about it, but today we're going to be detailing that the world is round. And then when we go to map out our grids, they are flattened. And because you have different areas of the world and obviously different countries, these grid lines can sometimes change based on which system you are using. So the map projections are flattened, and therefore each country will have a different coordinate systems, or multiple systems, maybe based on the size of the country now, or just the general data that's available. Things that can happen if you don't use a proper coordinate system, like you could have the exact mappings of a country, but they might be hundreds of kilometers out. Now, that's it is important to note we are going to show an example of a pitfall with using that type of information or the incorrect information in Revit. It is really important to note this for your project. So I'll just move on here. The things that we're going to be focusing on, the different origins in Revit. The first one is going to be the survey point. So this is for a known GIS or sort of site coordinate. This is normally on a grid line. This is normally where those grid systems come into play. You would set your survey point up based on a known grid system. Now the next one is going to be your base point. So this is the project base point, and this would normally be assigned to a building point or a location within your project and rotated to the true north value of the site that you're going to be working on. Now it's important to know the differences between them because this is where the errors would tend to occur. The third point is Revit's internal coordinate system. So this is only visible in later releases of the software, and it's a good projection on understanding the orientation of the project within Revit itself. And the last thing we're going to be talking about today is the actual location. So the map location for the site basically is important for any sort of thermal analysis or any analysis styles that you're going to be carrying out within Revit. We know there are plenty available, but you need to have the model set up properly to get the most accurate data out of it. Excuse me. So the things that we're going to be talking about here are the challenges. Now you can see here the survey point is at the lower end of the screen, the little triangle, and the base point is at the upper end of the screen. And this is a project that's been set up incorrectly, and the difference between these points is over 500 kilometers. Now, this is just, it's an unacceptable distance. There are best practices associated with setting these points up within Revit. And this is just, it's so far outside of those boundaries that it means that the project is not of great quality. The project setup is not assigned to any like GIS mapping location. It's been assigned to a base point, and this isn't the way it should be set up. So we can see up here, this is the base point, this is the survey point. The survey point has remained at 0, 0, 0, and the base point is the point that's located in space. But there is such a difference between them that when you zoom make sense to your project, you actually can't even see it anymore. So Autodesk have published sort of best practice of how to set up your models, basically checking the model's distance from the internal origin. Now, they detail that your project base point shouldn't be any more than 32 kilometers away from the survey point. So they do have tools in place to sort of, or like a workflow in place to sort of allow you to have a more robust project. Now, Victoria said everyone will be getting a copy of these of this webinar, so the resources will be available there for you, just to keep a note of it. Now, this webinar is going to be the same demonstration method as previous webinars. So what we're going to do is go through a series of short videos, and I'll just show you some of the key takeaways, the sort of key examples of where this information is put into practice. So the first one we're going to talk about is importing the point clouds. So this will be importing the point cloud as a reference. So this was briefly covered in a previous webinar. That was bringing in a file, a land XML file from Civil 3D to be used as a surface model for the site within Revit. Now, we're going to be talking about a few things here today. I will be showing you that workflow again today, but what we're going to do first of all is open and place the point cloud in Civil 3D. You can see here before I start this video that I have my track coordinates docked. So the top one is our latitude and longitude, and the lower one is the Irish grid coordinate system. Now, what I'm going to be doing once we bring the point cloud in is I'm going to find a spot that I want to reference my model from, and because I have the track coordinates available, I'm going to be able to take down the coordinates that I want to be the origin of the project within Revit. We're going to take those down. We're just going to make a note of them so we can then map our survey point to the correct place when we bring it into Revit itself. Now, I'll just start this video here. So Again, I'm going to open the point cloud and place it within Civil 3D, and we're just going to make the points a bit more dense here to get a clearer picture. So again, you'll see that the two coordinate systems are available. As I mentioned, we're just going to find the area within the point cloud that I want to base my design around. So this is going to be the corner of an existing building. Within Civil 3D, I can take off the X and Y coordinates that are displayed there. So we're going to take that down in a notepad format, and this is just for later use. So we're going to go back into Revit, and I'm going to make a duplicate of my site, so my existing site. So we're basically just going to put our point cloud reference on a duplicate of the site. So we'll rename it, and I'll change my orientation to true north. So you can see here we'll have both the survey point and the project base point visible. And we can change this within the visibility graphics as well. So the project's now being placed to true north and the orientation style, and I'll just open my visibility graphics here to toggle these site markers on and off. Now, it's important to be aware what the differences between these are. We did talk about them before, but we're going to show you an example of setting the right survey point. This is the correct workflow to detail this sort of information, okay? Now, bear with me 1 second. We'll just, this is the internal origin that's now visible. So you'll just see a XYZ sort of coordinate system. We'll just make the project base point visible. That is the circular point, and the survey point is the triangular point. Okay, so what we're going to do is use our data that we took from Civil 3D in the notepad to set our survey point at the correct location. Now, I've noted it down here. What we're going to do is we're going to unpin our survey point within Revit. Okay, first of all, actually, the purpose of doing that, I'll just actually rewind it here to show you. You'll notice that we've taken the decimal point out of these values purely because the units, the sort of site units in Civil are a bit different from Revit, so we're just updating this to accommodate for that change. That is important to note in the first instance there. So I'm just changing these values to make it readable within Revit. So just changing the unit values by removing the decimal point. Okay, and what I'm going to do here is go back into Revit. We're going to copy this rotation because we're going to change the survey point to the true north. I have to unpin the survey point first of all, and then what I'm going to do is go into my Manage tab and rotate the true north. Okay, this is according to the angles that I've taken, so it'll be that 56.435 will be my rotation angle. So I'm just going to enter that in, and again, this is the survey point. This is attuned with the Irish grid sense. So the coordinates that I took from Civil 3D are for the Irish grid mapping. So I'm going to take the X and Y. Now it's important to note Civil 3D outputs it as X and Y, but when you put it into Revit, it's Y and X. So the north and south value is actually the Y value from Civil 3D, and the east and west value is actually the X value from Civil 3D, whereas your elevation is going to be the Z coordinate that you're taking in. Again, that's important to note because you need to be aware of the differences to ensure that the coordinates are mapped correctly within Revit, okay? It's just another, it just takes into consideration the differences between the settings in the software and how the projects are actually set up in each. They don't necessarily talk to each other in this way, but the same information can be used to sort of modify or set up your project really, okay? Now I'll just continue on here. We'll put that data in. So now we're putting in our elevation, and we'll just hit okay. So our survey point is now set a location in space. I'm going to pin that back so it can't be changed. And when we turn the visibility graphics back on for the project base point, you'll see that it'll overlay my survey point. Now, the project base point can be moved anywhere, but it's now, they're all now set over that point in space that is associated with the Irish grid coordinate system. And you can just see all of our point data there, okay? So yes, that is our import of the point clouds. The next thing here in this video is we're going to bring in the actual ReCap file, and we're going to bring it in by shared coordinates. And you'll see that this will come in with the survey point directly on that corner of the building that we found the coordinates against in Civil 3D. Now, this is, it is important. We'll just navigate around a bit here. You can see that the levels are actually, they are just set at a point from 0, but we can actually also set the levels according to the survey point. So we can change the elevation based to the survey point, and the levels will change to give us the values of these levels above ground level. So if you need that type of information, it can also be quite handy. And it's important to note that that option is there so we can actually see the correct elevations and levels of this building. Okay, now the next thing I'm going to do is show you how to, well, not necessarily show you, we're basically going to model sort of a design intent sort of model based on this point cloud in Revit. Now, bear with me 1 second, sorry. I'll just hit play here on the video that we're pre-recorded. Now you can see the point cloud that we had just brought in. What I'm going to do here is draw a building outline of the existing building from level 1. Now, because we have our levels associated with this point cloud, it will allow us to create this building, include the walls, include a roof, that sort of thing. So once this is finished, we'll be able to see where the building sits within the point cloud. Now, it's important to note that sort of depending on your elevations and the quality of the point cloud itself will depend on, how this looks. Now remember, the point cloud is only a reference. So this is a model that we've drawn in Revit based on a reference file there. So we've done the outline. We can see that we can model off it, but if those of you who were in our last webinar, at the end of it, you would have seen that we created a surface. We brought in a surface based on the point cloud that we could actually model from. So what you see me doing here is importing what's called the land XML file. Now, the XML files are universal files that Revit can read. So land XML files can be taken out of any civil software. It doesn't necessarily have to be Civil 3D, and it can be read by Revit and brought into Revit. So we can see a surface present. So I'll just bring in the XML file that was created, okay? And it'll take a bit of time to process. So once it's processed, it will come into the model. Now, because we have our point cloud overlaid, we can't see it quite so clearly yet. But if we turn that off, you can see the outline of it here, but we can turn around and look at the elevation, and we can see that the elevation matches the point cloud itself. So we've taken a section here, and we can just see the cut section of this point cloud and of the surface model. Now, as I said there, what we're going to do is we're just going to turn off the ReCap point cloud model so we can see the surface, the topo surface by itself. Now, this is an important feature, is it allows you to create a usable modeling surface from the data that's been collected, whereas when we were drawn the building model off of the point cloud, it's just more or less, it's used as, it can be used as a reference. Okay, so it's important to note that. So we're just going to move on here. I'm just going to show you the incorrect process of this. So this is going to be, we had shown that example of the points being out by over 500 kilometers. This is the process that sort of determined that difference. Now, we're going to set the coordinates as before, so we're going to set it as before in the way that we set the survey point, but we're actually going to set the coordinates for the project base point this time. Now, again, I'm going to set the shared coordinates for the exact same values, but the only difference here is going to be that we're going to use a project base point rather than the survey point, okay? Again, both are visible here. They're both sitting at 0, 0. I'm just going to remove or change the visibility graphics so we don't get the survey point confused. Now, I have the project base point selected. I'm going to set the true north to the same value as I did before. So 56.435. And again, with that still being selected, we're going to specify the shared coordinates at the point. Okay, now again, same concept. We're going to put in the X and Y values. Now, if you remember in the previous example, once we had finalized this, the project base point came over and was situated in the same place as the survey point. But when we OK this and we change the visibility graphics back so we can see the survey point, you're going to see that it's actually, they don't fall on top of each other again. Like the internal origin of the project will follow along that project base point, but you can see here that the survey point is not in the same location. This is where our 518 kilometers comes from. This survey point is still situated at 0, 0, 0 rather than taking on the coordinates. So the important thing to note here is that the coordinates that we took out of Civil 3D are actually, they should be mapped according to a grid system. The survey point is the point that we need to reference that grid system. And in this case, it's not the survey point that's being referenced there, it's the project base point. And that isn't the correct process to map these items. So the base point still holds the internal origin, as I mentioned, but the difference between these 2 points is over 500 kilometers, and that's acceptable. The Autodesk best practice is 32 kilometers. Now you can see that when I bring that recap file in, yes, the project base point has come in the right place, but when we zoom extents, it isn't even visible anymore because the survey point is still at 0, 0. That's not at a point in space, that is just situated at a project origin. Now, if we bring the point cloud over this, you can see that it does map correctly according to that base point, but this is not best practice. This isn't the way the model should be set up. So I'll just move on to the last point that I had there about the weather data. Again, it's important to note that we need this for the analysis. So as I mentioned before, with these points, they're just points in space. And yes, the X, Y, and Z points that we have brought in, they are according to a grid system. But as far as Revit sees it, it is just a point in an area, but it doesn't have any sort of smart environmental data attached, and this is where assigning your location, weather, and site data comes into play. Now, what we're going to do here is you can see the bar for the project address. We can put in an area, we can navigate on the map to the point that we know is what we need the information for. We can put in the latitude and longitude of it, as you can see here. We're just going to find that area on the map, and you can see at the left-hand side there, Revit lists the weather stations, and it's this weather station data that you need to carry out any environmental, thermal, sort of solar analysis like that. You can see once it's placed, if we go into the weather tab, it's given us an average of the temperatures, and also it's given us a bit of site data there as well. So again, as the sort of cherry on top of your cake, it is important to have that weather data mapped correctly. So if you do have a very detailed model and you do need to run analysis on it, that is exactly what you need to go forward and do that. Now, to summarise what we've sort of just discussed in a technical aspect, are the rules of this is, you use the survey point as the shared coordinate system for this site. Like, it's the survey point that you specify the site coordinates on. You use the base point for a building corner in proximity to the survey point, and you rotate your true north value to that. So the survey point is your grid. This is your coordinates for the site, and your base point is the actual sort of coordinates, the origin of the building that you're going to be building on that site. Now, you need to make sure the base point, survey point, and internal origin are close to the model and adhere to the Revit guidelines, as we discussed earlier in the best practices section. So that information that Autodesk has put out to create a more robust model based on your coordinate system, that is what you need to adhere to make sure your model is sort of optimally placed against those coordinates. And the last point that you sort of need to take into consideration is the location of the site for the analysis. Now, it's all well and good putting in your coordinates and your survey point and your base point, but if you need to run any sort of detailed analysis on any model that you create or set up for shared coordinate systems, it needs to have a location set to get the most accurate and the most up-to-date data that is available. Yes, so those rules, that's basically the summary of the coordinate systems within Revit and how they can impact the likes of bringing in, for instance, the point cloud example that we had shown there. So it is important to be aware of that, and it is important to know the differences between each of these elements. Now, I'm finished with the technical aspect, but I'm just going to pass you back over to Victoria here. I hope that you find that informative, and as Victoria said, there is going to be a short sort of Q&A session at the end of this if any questions have come up that you want answered. Okay.
Brilliant, thank you, Aisling. I hope it was very beneficial for anyone who came and watched today. So as Aisling mentioned, just bear with us. I have a quick poll and some key takeaways before finishing up with Q&A. So there should be a poll that would pop up on your screen now. Would you consider working with Pentagon solutions to utilise your point cloud data if you're using them? So it'd be great if you could respond to this, and then you can just close it off your screen after voting, and then we'll give it a couple of minutes there and I'll just share the results. Okay, brilliant. I can see stuff coming in. Thank you very much. Okay, that's great. I will thank you for participating. I will just end the poll. Are we almost there? Actually?
Yeah, there's still a few hands left to vote.
A few seconds there.
Okay, that's actually very informative there.
Brilliant, thank you very much. So I'll just close off with some takeaways then from the series. Okay, so firstly, please make sure that you are utilising the tools that are currently available to you. If you have an AEC collection, ReCap Pro is actually part of the collection. Therefore, if you do have any standalone seats, AutoCAD, Revit, or whatever you're using, you should most certainly think about upgrading it to a collection to have access to all the latest tools and software to utilise what we are showing, and of course, at a much more beneficial cost. Also, please make sure that you are capturing your on-site data quickly through technological aids such as drones or scanners. You compute and take the data you gather through to ReCap to clean and analyse it. And then once, of course, you have imported the data, you're ready to start designing, and that's smart, detailed and knowledge-filled designs. So also don't stop there, don't leave your data on the shelf. Not to be used, include it in your workflows and binge projects. So with that being said, don't be afraid to get in touch. We can actually do any of these things mentioned today on your behalf. We can take your scans, pull them through ReCap, analyse them on your behalf and build your models or teach you how to do it efficiently yourselves. Some of the things shown today are of course covered in further depth in our training courses, but if you do have federated models or if you're working with people and are having issues, pick up the phone or drop us an email. We understand the importance of really good workflows. It's Pentagon's bread and butter, to be honest, so please do not hesitate to reach out. Lastly, I'd just like to mention for those interested in attending some more of our webinars, we actually have BIM 360 integrations with Navisworks coming up in a few weeks' time on the 17th of December there. So you can register for it today. There should be a link in the chat, or alternatively, you can register for it through our website at a later date. So I appreciate we've ran just a wee bit over there, but I'd like to just take 2 minutes to open up the floor to Q&As. So if you haven't already posted some, if you would like to post them in the comment section now, we'll be able to answer a couple of them. Okay.
So, yeah, we do have one in here. Is this a manual way of bringing in the point cloud first, then acquiring coordinates from the point cloud? So That's a good question. So see if a point cloud is obviously carried out from, if it's carried out from a scan, it'll have data included in it that that is smart. So that'll get modified in ReCap, that'll get cleaned up, and then when it's brought in to Civil 3D, if it's based on a scan, it does know where it is. But the thing is, within Civil 3D, that is where you would set up your so I mentioned there the likes of the Irish grid system. That's where you would set up the Irish grid system, and the point cloud will know where it's being mapped against that. So it's understanding those grid systems. So we have it set up in the Irish grid system in Civil 3D, and we know that location is where we're going to need to put it in Revit. So it's finding the coordinate within within that point cloud within Civil 3D, like that general coordinate that we can base our model off in Revit. So it's quite a smart workflow there. But if you have any more questions on that, then definitely give us a shout. My email will be at the end of the webinar here. What it was, I think there is there any more.
We'll just check the chat there for anonymous
ones
and stuff.
The chat.
Okay, yes. So we currently use the project base point. Is that wrong? Ashton, maybe you could share something on that.
Yeah, well, sort of the premise of the takeaways there is that it should be the survey point that's getting used if you're going to be mapping your project to like an actual designated system. So the survey point is for that GIS, the sort of the map data, whereas the project base point is actually just for a point in the building. So it is wrong if you should be using, like if your project through say like a BIM implementation plan, it should be carried, if you have a project that should be set at a certain coordinate system based on say Irish grid, it should be set according to the survey point and not the project base point. The project base point is only for building, sort of like picking the corner of the building, say, and using that as a reference within the project itself, but it shouldn't be used as your spatial mapped coordinate system, if that answers that question.
Brilliant, thanks Aisling. And I can just see one more there just before we wrap up. So we've received a project and I'm unsure of what point is being used. Can someone have a look at it? Yes, 100%. Do feel free to reach out. This is one of the services we offer, CAD consultancy. So do not hesitate to get in touch. We can follow up with you after. We see this a lot. So it's, as mentioned, our bread and butter. So yep, not a problem. We can take a look at that for you. Okay, I think that's us for today. Thank you so much for your time. I hope everybody has a lovely afternoon and thank you very much for attending.
Yeah, thank you guys. If you have any questions, technical or otherwise, based on this webinar or anything that we covered before, then please feel free to get in touch. But you will be getting these webinars sent out to you in recorded format anyway. But thanks for joining us and we'll maybe see you on the next one.
Thank you.